College Algebra, topic 5.4, solving exponential equations. We're going to solve number 7 by putting a logarithm on both sides of the equation. I'm going to put a log base 3 on both sides. Log base 3, 8, 4 minus x. Now, this gives me the ability to do two things. Make sure that looks like a 3. The fact that it's a logarithm, we have a property that allows us to take these exponents down as coefficients. So the x minus 3 comes down times log base 3 of 3. And the 4 minus x comes down, and you get log base 3 of 8. Okay, so that's the first great property of a logarithm. You can pull these down and make them coefficients. Next property I'm going to use is that if you have a base 3 if you're taking the logarithm of the same base, that is going to be equivalent to 1. So this actually simplifies down to a 1. Now log base 3 of 8 is actually a constant. So we're going to call that C. And we're actually going to work out that constant. Okay, so let's go here. So I'm going to use a change of base formula, which is going to be log base 10 of 8, close parenthesis, divided by log base 10 of 3. That changes the base to 10 here. We can evaluate that. Okay, now we're going to take that answer and we're going to store that with the store button right here into alpha C. Alpha C is here. Okay, press enter, and that represents the constant C. And every time we press alpha C, we will get that same value. Alright, now let's finish this out. When I distribute my 1, this becomes x minus 3. When I distribute this constant C, this becomes 4c minus xc. Okay, now we'll put the x's on the same side. This negative xc will go to the left side as a positive xc. And this negative 3 will go to the right side as a positive 3. Now that I have my x's on the same side, I can factor it out as x times 1 plus c equals 4c plus 3. Oops, sorry, no parenthesis there. Okay, and then I'll divide everything by the 1 plus c to isolate my x. So x is going to equal 4c plus 3 all over 1 plus c. Okay, now from here, I'm going to put this into the calculator as parentheses for the numerator. 4 alpha c plus 3, close parenthesis, divided by, open parenthesis again, 1 plus alpha c, close parenthesis. And that gives me a value of, this is approximation, 3.654 for x. Okay, now number 8. Number 8, we're going to use a substitution method here. We're going to let u replace all the e to the x's. So this will be replaced by e to the x. Well, if u is replacing all the e to the x's, then u squared would replace the e to the x times e to the x, which is e to the 2x. So we get two replacements. So all this now becomes, instead of e to the 2x, that becomes u squared. Instead of minus 4e to the x, we get minus 4u plus 3. Now we can solve this as a quadratic using u. So I want to factor this into two binomials, u times u for u squared, and 1 times 3 for 3, and two negatives here will still give us positive 3, but it will add together for a negative 4. And so u minus 1 set equal to 0, and u minus 3 set equal to 0 implies that u equals 1 and u equals 3. Now we just solved for u. But we know that u stands for e to the x. So we're going to go back to the e to the x notation. E to the x now equals 1, or e to the x now equals 3. And we're going to solve these. I'm going to convert these both into convert both these exponentials into logarithms. So this will be a log base e of 1 equals x, whereas this will be log base e of 3 equals x. Let's pull that up a little more. Now, log base e is actually natural log of 1, and log base e of 3 is natural log of 3. Okay, so the natural log of 1 will be 0, and the natural log of 3 will be 1.099. And both these answers solve x.